Here is a vacuum tube. At both ends of this tube are metal plates. The two plates are connected by cables. Next, attach a DC voltage source to this circuit. On the left metal plate, a negative charge will form. This part is also known as the cathode. On the right metal plate, a positive charge will form. This part is also known as the anode. However, this time, this DC voltage source can only produce an electric charge that is not too large. So, the Coulomb force between the two plates is unable to attract electrons from the cathode to the anode. In other words, electric current has not flowed through the electrical circuit. Well, now turn on the light source. The surface of the cathode plate will be exposed to electromagnetic waves. Photoelectrons are formed at the cathode. These electrons move towards the other plate, flow through the circuit, and move towards the original plate. Electric current begins to flow. If an ammeter is installed, the ammeter screen will display a certain number. Think of it as 1 milliamperes. Now, increase the voltage source to 2 times the original value. It turns out that the value read on the ammeter screen is still the same, at 1 milliampere. Now, increase the value of the source voltage again to 3 times the initial value. The current flowing is still 1 millimeter. The current value does not change when the source voltage is increased. Means this is the maximum value. This current is known as saturation current. In simple language, saturation current is the maximum electric current value at a certain wave intensity. Thus, the value of the maximum electric current that flows due to the photoelectric effect does not depend on the value of the voltage source attached to the electric circuit. This value depends on the intensity of the electromagnetic wave. We will study the intensity of electromagnetic waves in the next series. Hope it is useful. And don't forget to watch the next video.